dividing radicals, we talked about a couple of types. We've talked about ones. You don't have to write this down. Like this, where if we can divide them cleanly into a single radical, we do so. Okay. What would be the final answer to this one? Okay, let's do the division first. How'd you get that? Thank you. All done. Okay. So after we do the division, we always want to make sure, can we do it? Can we take the square root exactly? Can we break it down with the highest perfect square? How about this one? Can't divide it cleanly because, first of all, they're not both square roots, and we can't divide 2 by 7 cleanly anyway. Okay, so what do we do in this case when we can't divide cleanly? We actually divide by Really? You guys, we just did this, and you guys just did some practice questions on it, and you had no questions about the practice questions. How do I simplify this? Not quite. Multiply top and bottom by root 7. Does anybody remember what that's called? The fancy words we use. Rationalizing the denominator. What does that mean? It means we're turning the denominator into a non-radical. So what's 2 times root 7? To root 7, because you can't multiply them into a single anything. And root 7 times root 7. Keep going. Root 49, which is 7. Because we want to go as simplified as possible. Okay? So that's the type of division we've done so far. What about if we're doing some dividing and there's more than one term in the denominator? Well, this example here means we have to go 2 divided by 6, which we could do. What's 2 divided by 6? 6 divided by 2 is 3. What's 2 divided by 6? No. Yes. Can't divide it cleanly, leave it as a fraction, 2/6 reduces to 1/3. This we can't divide cleanly. Okay, so obviously we can't do an actual division. We're going to have to do something else to simplify because this has a radical in the denominator and it can't. What do you think we would do? Do you think we would multiply the top and bottom by something? Like we did up here to get rid of the radical? Maybe. The question is, what? No, I'm not going to let you answer. Because you know. I want to see if any of these guys. If you think back to the lesson we did on multiplying, there were certain multiplications we did where after we did the 4 multiplications, things canceled out. And we were left with just a number. If you remember that? Do you remember what we were multiplying by to get that? We call these two, what was that word we used? Conjugates. Okay? You can always get rid of the radicals in a binomial denominator by multiplying by its conjugate. Because after the multiplication, we'll see that the radicals cancel each other out and simplify to non-radicals. Whatever I do to the bottom, I have to do to the top. So that means I'm going to have to do a fair amount of multiplying. Because up top, I'm going to have to multiply 2 times 6 and 2 times root 5. And on the bottom, I'm going to have to do 4 multiplications. So there's quite a bit of multiplication involved whenever there's 2 terms in the denominator and 1 or more is a radical. Well, you guys know how to multiply. 2 times 6 plus 2 times root 5 to root 5, because we can't multiply them together into a single thing, so we just leave it as a multiplication. On the bottom, 6 times 6. Sorry? 36 plus 6 times root 5. What's 6 times root 5? 6 root 5. Minus root 5 times 6. What's root 5 times 6? 6 root 5 again. Minus root 5 times plus root 5. Root 25. Okay, so we've done all the multiplication. Now we need to simplify as much as possible. Can I combine anything up top, or can I simplify anything up top? Can I do anything with these? I'm not looking at the bottom, just the top. I can put them together? No, they're not like radicals. This I can't take exactly, this I can't, there's no perfect square that goes into it. I can't do anything to the top, but I can do some stuff to the bottom. What can I do to the bottom? Those cancel each other out. When we multiply conjugates, the 2 middle terms will always cancel each other out. Anything else I can do? Yeah, what's the square root of 25? It's 5. So I actually end up with 36 minus 5. 31. And look at all the non-radicals. Can I reduce them all by something? No. So that's as far as I can go. We're not going to do this one, by the way, D. We'll leave that one. Okay. B is a similar one to A. There's a single term up top. There's 2 terms on the bottom. As soon as you see 2 terms on the bottom, and one or more of them are radicals, you've got to multiply by the conjugate. What is the conjugate of 4 plus root 6? 4 minus root 6. And whatever you do to the top, you do to the bottom, you do to the top. So again, I've got 2 multiplications up top. I've got 4 multiplications on the bottom. 5 root 3 times 4. 20 root 3. Minus 5 root 3 times root 6. 5 root 18. Good. Now the bottom, 4 times 4. 4 times minus root 6. Minus 4 root 6. Positive root 6 times 4 is plus 4 root 6. And plus root 6 times minus root 6. Root 36. Or if some of you just want to go straight to the simplified answer of 6, that's fine too. Okay, so I got to see what I can do here. Can I do anything up top? Well, first of all, can I combine them? No, because they're not like radicals. They have to have the exact same numbers under the radicals. I'm glad. We want to keep hammering this home. Okay? Look at each radical. Could I simplify or take one exactly? Well, can I take the square root of 3 exactly? No. Is there a highest perfect square that goes into 3? No. So I can't do anything. But what about the root 18? I can break that down to root 9 times root 2, and then I'm going to times it by 5. On the bottom, every time we multiply by the conjugates, the two middle ones on the bottom will cancel each other out. What's the square root of 36? So actually, I've got 16 minus 6 on the bottom now. What's this the same as? Root 9 times root 2. How do I simplify that further? 3 root 2. So I've got 20 root 3 minus 5 times 3 times root 2. Minus 15 root 2 over 10. Now, we're dealing with fractions. It's possible to reduce. First of all, you never reduce the radicals. Never. We've already simplified the radicals up in these steps. Look at the non-radicals. Can I reduce all the non-radicals by some number? I could divide them all by. So I could divide this by 5 to get 4, this by 5 to get 3, and this by 5 to get 2. So my final simplified answer is going to be 4 root 3 minus 3 root 2 over 2. Okay. C. Notice I put the original in parentheses to remind myself that I'm going to have to do lots of multiplications. What am I going to have to multiply this one by? Yep. Yes. So remember, we want the bottom to be non-radicals. So what would we multiply by? Look at the previous two examples, you guys. Root 5 minus root 6. Excellent. And whatever you do to the bottom, you do the same thing to the top. It's always the conjugate of the denominator because we're rationalizing the denominator. The numerator can have as many radicals in it as you want, but the denominator can't have any. Okay, so we've got lots of multiplications to do here. We've got 4 up top and 4 on the bottom. Root 2 times root 5. Root 2 times root 5. Root 10. Don't overthink, you guys. No more than you think. Minus root 2 times root 6. Root 12. Plus root 3 times root 5. Plus root 3 times minus root 6. Come on, guys. Root 3 times root 6. Thank you. On the bottom, root 5 times root 5. Root 25. Root 5 times minus root 6. Minus root 30. Root 6 times root 5. Plus root 30. Root 6 times minus root 6. Okay. Can I combine any of the radicals up top? No, because they're all different numbers under the radicals. So I got to look at each one and see if I can simplify them. Well, root 10, I can't take exactly. There's no perfect square. What about root 12? Doesn't that break down to root 4 times root 3, which is 2 root 3. Can you do anything with root 15? No. What about root 18? Root 9 times root 2, which is the same as 3 root 2. Okay? And there's still nothing I can combine up top. So that's as simple as I can go up top, because there's no like radicals there that I can add or subtract together. So the bottom, lots of simplifying on the bottom. Cancel these in the middle, first of all. This is 5. This is 6, so I end up with 5 subtract 6. Negative 1. Can I go a little further? If this was positive 1, I don't have to write over 1, do I? But if it's negative 1, can't I just change all these to negatives and then the fraction disappears? Because 10 divided negative 1 is negative root 10. Negative 2 root 3 divided negative 1 is positive 2 root 3. Root 15 divided negative 1 is negative root 15. And negative 3 root 2 divided negative 1 is positive 3 root 2. So I could make it a little simpler and they'll end up being no fraction. Okay? That's dividing radicals. So we've done all the operations with radicals. You have known from previous grades how to take radicals exactly. Okay? From last year, we learned how to simplify radicals by breaking them down, highest perfect square or highest perfect cube, whatever. But notice with the operations, all the radicals we've been dealing with are square roots.